This video is about the design of raised embankment and bridge approaches. This is part of the road which connects the normal road embankment, which is normally lower in height, and the bridge structure, which is higher due to the requirement of clearance for traffic underneath the bridge. The second drawing provides detailed reinforcement of the retaining wall. The elevation view show here typical reinforcement of a 10-meter wall, and the plan view which indicate the information of the base. The ground where the embankment is to be constructed is rather poor in bearing capacity, thus the embankment need to be supported on pile to carry the embankment field as well as the road surcharge. In this drawing you can see the plan view of the embankment slab shown in this detail, where square piles are proposed at a spacing of 3.2 meters. At the interface where normal embankments meets the pile embankment, a transition slab is also proposed to avoid localized settlement of embankment. Another main function of this transition slab is to provide smooth riding condition for road users, as the change from flexible embankment to rigid embankment zone will create harm to the drivers. The third and the last drawing that we're going to look at is the drawing that shows the detailed reinforcement of the retaining wall. As we have shown earlier, the height of the wall varies from 2 meters to 8 meters. To simplify the design and site works, as well as for fabrication of formworks, cutting of reinforcement steel, 6 different types of wall was proposed. These are the information of the reinforcement as well as the height provided in this table shown here on the right hand corner, and detail of the reinforcement for type A until type F are also shown here. If you can see, there are different types of footings for this wall. This detail were based on the height of the wall as well as the ground conditions. For type A, type B and type C, the wall were designed based on bearing capacity of the soil. Type D was also designed for bearing capacity. However, there is a key provided on the at the bottom of the base slab. This is to resist the horizontal force. Type E and type L are a bit taller than the rest, and the force required to sustain the bearing capacity is too high for the soil. Thus 250 millimeter diameter piles were proposed, and you can see the pile will also rake the front portion of the piles was straight, and the one at the backs are raked to a certain angle. It is about 1:4 from these drawings.